So this video will walk you through confidence intervals and how to estimate them in Excel, and also how to use a tool that I put together to help you visualize the confidence interval. So this is the problem that we had in the notes. So we have 126 monthly returns for Tesla. The sample mean was 5.49%. Sample standard deviation was 18.56%, and we wanted to estimate the confidence interval, the 99, 95, and 90% confidence intervals for the true monthly return for Tesla. And this is the 99% confidence interval. So this t-value was given to you. So this is the number that we use. So if you go back and look at the confidence interval right here, so this is the sample mean. This is the standard error. So this S over square root of n, that's the standard deviation of the sampling distribution. This t-value is what we use to scale the size of the interval for the appropriate level of confidence. So if you want to increase the level of confidence or decrease the level of confidence, that's going to affect the size of the interval. And I'll give you this number in this problem. I'll show you how to generate all of this separately in Excel. So if you look at these intervals, the 99% confidence interval was the widest, because if you want to have the most confidence, you're going to have a wider interval. As you decrease the level of confidence, the interval gets narrower. So I'm going to show you this tool right here that I put together for the confidence interval, where you can set the level of confidence up here at the top. I have it all the way down to 80, 95, or 90 is as low as you ever really want to go. Once you start going below 90, that's not a high enough confidence level to really be meaningful. So we set the level of confidence at 99. The sample size was 126. The sample mean was 5.49%. And the sample standard deviation was 18.56%. And that produced an interval of 1.1. Again, these numbers are slightly different because there's rounding error in the slides, from about 1.17% to 9.82% was the confidence interval. So we're 95% confident or 99% confident that the true mean falls somewhere inside of this interval. And as we lower the level of confidence, so the only thing I'm going to change in this problem is the level of confidence. And notice it's not going to change the sample mean. It's not going to change the sample standard deviation. It's not going to change the degrees of freedom, which is that n minus 1. It will change the critical t-value and the margin of error in the interval. So if I go down here to 95, notice the interval is getting narrower. So when I go to 95% confidence, the margin of error is smaller. And the margin of error gets smaller because you have less confidence in the interval. So as you lower the level of confidence, that critical t-value is going to get smaller, which makes the interval smaller. So now with 95% confidence, we believe the true monthly return is somewhere between 2.22% and 8.76%. If we go down to 90% confidence, notice the interval gets even narrower. So the lower level of confidence, the smaller the interval. But let's go back to 95% confidence. And how can we get a narrower interval? So how do we get a more precise estimate for the same level of confidence? Well, we have to increase the sample size. So this is a sample size of 126. And notice what happens when the sample size gets larger. The interval is going to get narrower and narrower. So if you look at this margin of error right here, this margin of error is going to get smaller as we increase the sample size. And that smaller margin of error is going to shrink the size of the interval. So if you want a smaller if you want to have the same level of confidence in a smaller interval, you need more data. You increase the sample size. So if we go back to our original sample size of 126, this is the margin of error, and notice how much smaller it got when we increased the sample size. The other thing that would cause the interval to get narrower is if we decrease the sample standard deviation. And again, you can't do this on your own. You can't choose a smaller sample standard deviation. It is what it is. But if the sample standard deviation was smaller, notice what's going to happen is this margin of error is going to get smaller as well. So let's just say the sample standard deviation instead of 18.56 was 10.56. And notice how much smaller the margin of error is now. So the margin of error is going to get larger if I increase the sample standard deviation. The margin of error is going to get smaller if I decrease the sample standard deviation. Again, we don't have any control over the sample standard deviation, but if your sample has a lot of variation, you have a wide range of values in your sample, your confidence interval will be wider to reflect that. And if you have a small amount of variation in your sample, so all of your sample, you have your observations are close together, that will be reflected through a narrower interval, and that's coming through that margin of error. So you can play around with this tool, and it'll show you how changing different parameters or different statistics or different values change the confidence interval. So again, if we change the X bar, the only thing that changes is the location. Notice that nothing changes except where it's centered, because that's not affecting that plus or minus portion of that margin of error. So you can use this tool to check your work. You can use it for practice to make sure you can do the problems in Excel and get the same answer that you get in using this tool. But on an exam, when you submit your Excel file, I need to see the Excel functions that you used to generate the interval. So if you use this just to plug the answers in, you're not going to get credit because I'm going to know you use the tool. Your Excel file needs to be consistent with the answers that you submit. So let's just move over to Excel real quick. We'll estimate a confidence interval in Excel, and I'll show you how you can check your work with that tool. So this is the same data that we had earlier with Tesla and Microsoft. Just to be consistent, I'm going to use the same data. So the first thing we want to do anytime you start with a problem like this is to generate the returns. So remember, it's always current divided by previous minus 1. So we're going to do B3 divided by B2 minus 1 for Tesla. We'll drag this over, run that down. So that's going to give us all the monthly returns for Tesla and Microsoft. We only need a couple statistics here. For the confidence intervals, we need the mean, the sample standard deviation, and the number of observations. Everything else we can set, or we'll use a function to generate. So the mean is going to be the average of, again, make sure you always do the return column. So in this case, it's D colon D. The sample standard deviation is going to be stdv.s, D colon D. The sample size, this is a function we haven't used yet, but we use count. And it will count the number of observations in that column. So count D colon D. And it knows to ignore the Tesla return heading. So that's not showing up as an observation, and it ignores that blank. So if you scroll down here to the bottom, we're going to go to row 121. But we lose one because we don't have the first observation and that. So we know it's counting correctly. And we want to do this for Tesla and Microsoft. So our Tesla return was higher, but it also had a higher standard deviation. The sample sizes are the same because we're using the same time period for both returns. So when we look at this, we already know that the confidence interval for Microsoft will be narrower than the confidence interval for Tesla, because the Tesla standard deviation is smaller than the Microsoft standard deviation is smaller than the Tesla standard deviation. So we know that whatever interval we choose, whatever interval we construct, will be narrower for Microsoft than it will be for Tesla, because everything else is going to be the same. So the confidence level is something I will give you. It's not estimated from the data. So we want to put 95% here just to make our life easier. So we only have to update one cell. I'm going to let this value equal the value next to it. So when you set it up that way, if I change this, it also changes that one. That way you only have to make this change once. So if I want to go to 90 here, that also updates to 90 because this is just referencing the cell next to it. Alpha is always 1 minus confidence. So this is going to be equal to 1 minus the level of confidence that we have in cell H5. So alpha for 90% confidence will be 10%. Again, just drag that over so it's the same. So notice if I update this to 95, everything updates. So you're not having to change more than one cell when you update the problem. The margin of error, again, that's the t alpha over 2 n minus 1 multiplied by s over square root of n. You can calculate all those separately. You can do this manually if you want to, but there's a function that we can use called confidence.t, and confidence.t will generate the margin of error for you. It does everything you need it. It puts all of it together. So the margin of error function is not margin of error, it's confidence.t. And you have to do confidence.t because we're using the sample standard deviation. If you were using the population standard deviation, you would not have to, you would use confidence.norm. But if you know the population standard deviation, you know the population mean, so the entire process is useless because we have what we need already. So confidence.t, the first thing you enter is alpha. So this is going to be the value for alpha, H6. The standard deviation is going to be the sample standard deviation, so H3. And the sample size is the number of observations, which is H4. And if we drag that over, this is the margin of error for Tesla. This is the margin of error for Microsoft. And as expected, the margin of error for Microsoft is smaller than the margin of error for Tesla, and it's smaller because the standard deviation is smaller. The standard deviation is about a third. The Tesla standard deviation is about 3 times greater than the Microsoft standard deviation. Our margin of error for Tesla is about 3 times greater than the Microsoft. So that's what we would expect. Now, the lower bound and upper bound for the confidence interval, the lower bound is x bar minus margin of error. The upper bound is x bar plus the margin of error. So that lower bound is going to be the sample mean minus the margin of error. And the upper bound is going to be the sample mean plus the margin of error. So 1.07% to 7.62. If we copy this and bring it over for Microsoft, notice it's referencing all the correct cells. Our confidence interval for Microsoft is 1.18% to 3.42%. So based on this sample, we're 95% confident that the true monthly return for Tesla is somewhere between 1.07% and 7.62%. And we're 95% confident that the true monthly return for Microsoft is somewhere between 1.18% and 3.42%. This interval is narrower than this one because the margin of error is lower. If you want the 99% interval, just change this to 99. And now we have the 99% confidence interval for Tesla and Microsoft returns. And notice the interval is wider than the interval for 95% confidence. We could do 90. Then notice the interval is narrower than the 95% interval. So that's how we estimate confidence intervals in Excel. Again, you have to get the returns, then estimate the mean standard deviation sample size. You set the level of confidence based on the problem that you're solving, and then use the confidence.t to get the margin of error. And this is just a simple formula, x bar minus margin of error for the lower, x bar plus the margin of error for the upper. So let's take these values and see if we can enter them into that this calculator and see what we get. Actually, let me put this to the right and this. to the left. All right. So we're going to put these values in here. Again, our numbers are not going, they should be pretty close here. They'll be off a little bit just because of rounding error in the sample mean and standard deviation, because we're entering them in Excel. I mean, we're entering them here, and they were computed very precisely in Excel. So our sample size was 119. Our sample mean for Tesla was 4.34%. Our sample standard deviation was 18.03%. And we want to look at 90% confidence. So we're getting a confidence interval of 1.6 to 7.08, which is exactly what we're getting over here. Our standard deviation, sample mean are the values that we entered. Degrees of freedom, that's just sample size minus 1. So that's 118. Our critical t-value, I didn't have you calculate this, but that's what it would have been if you tried to estimate that margin of error by hand. The margin of error is 2.74, same thing we're getting in the Excel problem. And then this is our confidence interval, 1.16% to 7.08%. So we're 95% confident that the true mean falls somewhere inside of that interval. And if we want to change the level of confidence to 95, we can just drag this up. There's our 95% interval. Notice it got wider. And if we go up to 99%, notice it gets even wider again. So that's how we estimate confidence intervals in Excel. And you can use this tool. I'll post a link to this so that you can use it to check your work and just visualize the interval.